Hello friends, welcome to our channel. Let's have a look at problem 498, diagonal traverse. In this video, we're going to explain this problem in two main points listed here. First, we're going to look at the problem statement because it's rather short. So basically, we are given a matrix which says m by n. So we want to return an array of all the elements of array in a diagonal order, and depicted here. This direction and the reverse and the reverse and reverse, right? So here the constraint, basically this first four items defines the problem size, because the number of cells is bounded below by 1 and bounded above by 10 to the power 4. And the last one basically tells us that the elements can be 0, can be positive, and can be negative, right? So this problem is rather easy to digest, but if you want to do coding quickly, you need to understand how to retrieve that in an efficient way. So here, let me explain the points and then write the code. The point is to know the relation for the diagonal parallel lines, its equations, right? So it's rather simple. For example, this red line here corresponding to the row index plus column index equals 0. So this red line corresponds to the sum equals 1. And this one corresponds to r plus c equals m minus 1. And this one corresponding to, because this is the m minus 1 row, right? The column is 1, so corresponding to m. So the last one actually is corresponding to m plus n minus 1, right? This is very important to notice. So in total, how many lines? 1, 2, 3, 4, 5. So it equals to the number of rows plus number of columns minus the common one, that is 1. So this is in total m plus n minus 1. So the largest index will be this number, minus 1 again. This is the one point. So the second point is that then we can just use a flag variable to mimic the direction change, right? You can use 1 and then multiply by negative 1 with negative 1. So switching, right? So it's with 1 and 2 digested. So writing a solution should be just a plain traversal. That's very straightforward. So now let's look at the coding. So I changed this signature to be capital M just for convenience. And then first I'm going to initialize a result variable. So this is to hold the final result. And then let's track the number of rows and number of columns for convenience. So next, so we use the flag variable to be 1. 1 means from this direction upwards, right? And then, so we are going to, how many lines we have? We have this number of lines for the sum in range, so m plus n minus 1, right? So then basically we want to consider these lines for r plus c equals s. So r means row index and c means column index, right? So let's get the current cells, right? And then what we are going to do, if s is less than m, then so we should start from I will be 0, 1, 2. This is the m minus 1, right? So basically for I in range s. So actually later you can shrink those cells. So for this is the I index. The j index will be s minus I, right? And then if j is inbound, right? And then what we are going to do, we are going to append the current m, I, and j. So here I corresponding to r and j corresponding to c, right? Otherwise, if j is auto set, just break, right? Next here you cannot continue. So this is one case. Otherwise, so s will be larger than or equal to m. So basically for I, so this is the range of m from m minus 1, and then we can also for this row m is always m minus 1, right? So and and then what we are going to do is, so this is negative 1, right? So we start from m minus 1 up to m minus 2, like this. So then j equals s minus I. The same thing, right? So if j is inbound, So what we are going to do, append this mig, right? Otherwise we just break. So this constructs the current, right? So then basically what we want to do, if flag equals 1, because this direction, so we just add the current list to the result. So what we do is result extend, right? Then you can have this current. So the extend method for list is you have an iterable, and all the elements will be appended to the result from the back. So otherwise, so result should be extend the reverse of this one. Then after we do this operation, what we do is flag multiply equals -1, changing directions. So once you have this, you just need to return the result. So this is the full code for this problem. Now let me run it to a test. So it passes 2 cases. So now let's look at the generic case. It passes all the cases. So now to better understand this, so basically you can do a print, right? So print s. So let's see, what's the s, right? And what's the result status, right? So this is before and then after, right? And also I think we need to have the flag, right? And then let me copy this part and put it here, and then print a new empty line, right? So yeah, so here we can look at the first example, right? So originally it's before you enter this 0, it's corresponding to 0. So after you exit 0, so this is the result equals 1. So next you are going to have 2, 4, right? So 1, 2, 4, right? And the next you are going to add 7, 5, 3. So 7, 5, 3. And next you are going to have 6, 8. 6, 8. And then you're going to have none, right? So you can see the flag alternating, right? So you can also see example 2. So this is rather easy. So you have 1 first added, and then you have 3, 2. So you want to have 2, 3. So you have 1, 2, 3, and then you are going to have 4, right? So with that said, I guess that's it for the current problem and current video. If you are interested, you are welcome to follow up other problem videos in our channel. Thank you for